Let's look at factoring by grouping. For example, let's factor the following expression by grouping. Now, to factor means we want to write this expression as a product of other numbers or algebraic expressions. Now, looking here, there is nothing in common to all four of these terms. And when that's the case, we try to group terms together and look for common factors. And we can begin by trying to group the first two terms together and the last two terms together. In other words, this is equal to 4v to the fifth plus v to the fourth, and then plus 20v plus 5. And now the greatest common factor in the first two terms is v to the fourth power. Factoring that out, we're left with 4v plus 1. And the greatest common factor in the second two terms is a 5. Factoring that out, we're left with 4v plus 1, which is the same binomial expression in the first grouping, which is why factoring by grouping works here, because now we can factor that out of both of these. In other words, this is equal to 4v plus 1 times v to the fourth plus 5, which would be our answer. Let's look at another example. Again, let's factor this expression by grouping. And we'll start in the same way. We'll group the first two terms together as well as the last two terms. In other words, this is equal to 5w cubed minus 4w squared plus negative 25w plus 20. And now the greatest common factor in the first two terms is a w squared. And when we factor that out, we're left with 5w minus 4. Now, what is the greatest common factor in the second grouping? Well, we could factor either a 5 out or a negative 5 out. But remember, our hope is that we're going to get the same binomial left over. So what happens when we factor out a 5 here? We'd be left with negative 5w plus 4, which is not that same binomial. However, if we factor out a negative 5, we're left with 5w minus 4, which is that same binomial. So that's what we want to factor out, is the negative 5. So this is minus 5 times 5w minus 4. And now we can factor this binomial out of each of these groupings, which gives us 5w minus 4 times w squared minus 5, which would be our answer. All right, let's see one more example. Again, let's factor this by grouping. And we'll begin in the same way. We'll group together the first two terms and then the last two terms, which gives us 3pr minus qr and then plus 6ps minus 2qs. Now the greatest common factor in these first two terms is an r. When we factor that out, we're left with 3p minus q. Now remember, our hope is to get the same binomial left over in the second grouping. And if we pull out a 2s, we'll be left with that same binomial, won't we? 3p minus q. So let's do that. So we have plus 2s times 3p minus q. And then factoring that out of each of these groupings gives us 3p minus q times r plus 2s, which would be our answer. Now, in all these examples, we've been starting with grouping the first two terms and then the last two terms. But what if we started a little bit different here? So we still have this expression, 3PR minus QR plus 6PS minus 2QS. But instead of grouping the first two terms and the last two terms, what if we grouped the first term and the third term together, and then the second term and the fourth term? In other words, let's write this as 3PR plus 6PS plus negative QR minus 2QS. Now the greatest common factor in the first two terms is a 3p, so let's pull that out. And we're left with r plus 2s. Now remember, in this second grouping over here, our hope is that after factoring, we have the same binomial left over. So if we factor out a negative q here, we'll be left with r plus 2s, which is the same binomial. So let's do that. So we have minus q times r plus 2s. And now we can factor out that binomial, which leaves us with r plus 2s times 3p minus q. And by commutativity, that's the same as this, isn't it? Okay, and this is how we factor by grouping. Thank you, and we'll see you next time.